there is a positive real number x not equal to either 1 over 20 or 1 over 2, such that log base 20x of 22x is equal to log base 2x of 202x. The value of log base 20x of 22x can be written as log base 10 of m over n, where m and n are relatively prime positive integers. Find m plus n. Okay. So I guess we're just going to be doing a lot of manipulation of logarithms and using laws of logarithms and so on, and try to get things into a nice form. I don't know if we will actually solve for this value of x, or if I just manipulate things to get to try to get this value of log base 20x of 22x. I also don't really have a plan, like a specific direction of how to do this. I'm going to start by just fumbling around to see if I end up with something that looks like it might lead me in a reasonable direction. Okay, so what we really want to find eventually is log base 20x of 22x is equal to log base 10 of m over n. We want to write this number in this way, okay, but we're starting with the original equation. So, I mean, the first thing I'll probably try to do here is just use law of logarithms to rearrange this in a way that might help us somewhere. 20x, 22x, this is equal to log of 2x, 202x. So it says there's a positive real number not equal to 1 over 20 or 1 over 2. Does that mean if x is equal to 1 over 2, is that a solution to this? I imagine the two numbers that I gave are already solutions to this, and that there is another positive solution. But I'm going to write this as log 22x divided by log of 20x is equal to log of 202x divided by log of 2x. So here we have log of 22 plus log of x divided by log of 20 plus log x is equal to log of 202 plus log x divided by log 2 plus log x. Do I want to multiply through? I mean, I guess that's probably what we should do. Multiply through by both of the denominators, because then we will get log x to the power of 3, which leads me to, a cubic has in general three solutions. We're given two of them. Maybe we can use those two solutions to find a third. I don't know. But I'm just going to proceed and see if something nice comes from this. I'm going to multiply through by the denominators. Wait, will I get a cubic or will I just get quadratic? Huh. Okay. write it on 2 lines. I don't normally like doing that, but... And the quadratic is going to cancel from both sides. So I'm not sure if that's a good thing. Oh, I see. The reason they've gotten rid of the roots 1 over 20 and 1 over 2 is because then, of course, in the original equation, if x is equal to half, then I have log base 1, which doesn't, I'm not going to say it doesn't make sense, but it's not a function we want to talk about. And same with this. This would become log base 1. So, so much for the cubic idea. Okay. Let's just continue with what we have here. Expanding everything. Okay, so log squared cancels from both sides. Do I have any other common terms? I have 22, 2, 202, and 20. So no, I don't think so. Although everything is linear or constant with respect to log x. So let's put everything on sort of respectively one side of the equation. Log 22. I'm also going to say let y be equal to log x. Then I've got log 22y plus log 2 of y minus log 202y minus log 20y is equal to log 202 log 20 divided by, minus log 22 log 2. So the left-hand side is that. Now I'm thinking about writing things like factoring these numbers. 22 is 2 times 11. 20 is 2 times 10. But we'll see if there's a clever... Oh, and I'm not even trying to solve for x. I'm trying to solve for log... So maybe there was a more clever way of doing this. Let's yeah, I don't want log x, although we have it now. It's pretty messy, but we have it. Oops. Like there's a lot of log base 2s that might be able to cancel out of certain things here. If I replace all these logs with log base 2, nothing changes, right? I mean, I sort of implicitly used natural log in all of this, but I could have used log base 2 everywhere there. I'm not really sure here. I feel like I'm running in circles and running into dead ends. I don't know if, I mean, I think I've written down about as simplified a form for log of x as possible. I tried just manipulating directly the quantity we're trying to solve for, and I get this, but that doesn't seem to be leading anywhere. I doubt this would take us anywhere nice. Like, I really don't want to take this and, maybe manipulate that to turn it into the quantity we want, log base 20x of 22x. Yeah, I don't know. I feel like I've gone down this path so long that I'm not gonna see what the correct thing is. Like I don't know at this point even if I don't even know if this is a a good first step. And I'm failing to see anything else that you could possibly do. So I'm gonna have to give up on this one. Yeah, I mean, it looks like a really interesting problem, but I've stared at it too long. I don't have any other new ideas. So too bad I didn't even come up with a wrong answer. Thanks for watching.